Good morning. Welcome to the G2M Research Multi-Vendor Webinar number 3. This webinar is going to be on NVMe All-Flash Array and NVMe OF All-Flash Array use cases. Today our sponsors are E8. We have Julie Hurt from E8 here, Nuisis, Dan Liddell, and SolarFlare, Tom Spencer. Just go through it really quick, some of the ground rules. So if you have questions, please type them into the Q&A box. You'll see that on your Zoom control panel, and then we'll answer all the questions at the end, but please type them in, then we can read them off, and I will consolidate questions if I see questions that are similar, and we'll kind of go through that. The other piece of it for all of you that typically ask the question is, will there be a recording of this, and will the slides be available? The answer to both questions is yes. Sometime tomorrow or Thursday, we'll post both the recording and the slide set to the G2M Research website, and we'll send a link out to everybody who has registered for the webinar. We'll show you how to get to those. So those assets will be available to everybody who registered, whether you attended or not. A couple other things, just going through the agenda real quick. I'll talk for a couple of minutes about all-flash arrays and NVMe and how those kind of are evolving together. Then each sponsoring vendor will talk for about 5 minutes. And then we'll do 4 or 3 key questions that we'll ask each vendor, and they'll each get 4 minutes to respond. Then we'll have intermixed within that 4 audience survey questions. Those are electronic. You can do it on the poll button through the Zoom control panel. And then we'll go into Q&A. The whole webinar should last about an hour and 15, hour and 20 minutes. With that, let's go ahead and get started. So with us is Julie Hurt from E8. Julie is Director of Technical Marketing at E8 Storage. Dan Liddell is representing Nuisis. Dan is the VP of Marketing. And Tom Spencer is Senior Director of Product Marketing at SolarFlare. He'll be representing them, and then I'm the guy in the bottom. So if you kind of look at storage arrays, historically they've been, back in the days when I started doing storage, are multi-rack systems that typically connected to director-class fiber channel switches and took up large parts of the data center, were very expensive. Today it's a little different. You see storage arrays are disaggregated and they're networked together. So oftentimes controllers and media enclosures are separated, and that's something that NVMe over Fabric has actually accelerated to where you can have these things all separated. You can have enclosures shared with multiple controllers. It certainly improves performance management, and it also improves provisioning and availability. One of the other things that's obviously kind of changed about things is back in the day, once we got RAID and everybody kind of had RAID, the next thing that came up were a variety of data management capabilities, things like compression, things like dedupe, active agents to do backups, all that kind of stuff was trying to be done on the arrays. I think as we've seen today, and we see people using different virtual arrays, kind of some of those concepts have changed. And that's something hopefully some of our panelists will be talking about as we go through this today as well. And so we certainly have some questions on that. The third one is obviously, the cloud is big today. And while not everybody is using the cloud 100%, certainly the ability or desire to integrate with the cloud for, say, backup has become something that's been very powerful as well. So that's another thing we'll talk about as well. So if you look at kind of how flash, NVMe, and 100 gigabit Ethernet changed the storage landscape. So obviously, flash really reduced storage media latency. Back in the days when I worked for a disk array company, or an array company that used disks, I should say, you often have large amounts of RAM. You have a lot of disks that you short stroked. You only use part of the disk to increase the speed. Flash kind of got rid of all that need to do all those kind of funky things to try to make things fast. NVMe has made that even more so, as it's kind of closed the gap between RAM performance and flash performance. Does this reduce the importance of the array controller? I don't think so, but we'll let our guests talk about that. But certainly, I think it makes the job of the array controller much easier, which has allowed us to see some new people come in the flash world and change things. One of the other big changes, obviously, is Ethernet. Right now, the fastest speed on fiber channel, I've worked for all 3 fiber channel host bus adapter companies, and I've worked for companies that made Ethernet cards as well. So I don't feel I have one bias one way or another, but the fastest fiber channel you see deployed today is 32 gig. Ethernet, obviously, you can go up to 100 gig, whether it's Rocky or NVMe over TCP. You can get very fast Ethernet that people network with. On the other hand, there's a lot of installed base of fiber channel out there. Fiber channel is a dedicated SAN as opposed to a converged SAN LAN like Ethernet. So certainly one of the questions that as you look at your array choices, you need to think about. The good thing is most arrays support both options, so it's not like you're stuck with one or the other. And kind of the final thing, if you look at array controllers today, 20 years ago, most array controllers had ASICs that were developed specifically for them. Today, you see most of them based on x86 architectures. Some have FPGAs or ASICs, but for the most part, most of the heavy lifting is actually done on x86. So kind of important questions for users, and these are some of the things we'll talk about as we go through the webinar, is the first one, what is your use case for an all-flash array system or for an NVMe-based all-flash array system? There are definitely some use cases that really can take advantage of flash and NVMe specifically, and we'll talk a little bit about some of those in the webinar. The second one is, as you migrate from a hard disk drive-based system, does that give you the opportunity to consolidate your storage systems and save some money and save some footprint within your data center? The third one is, do you really need to integrate with the cloud? And how are you going to use cloud storage? Is it going to be overflow storage? Is it going to be backup storage? And then finally, what are your ROI expectations and are they realistic? I think we all know companies who have went and implemented something expecting a large ROI and for one reason or another didn't get it. So keeping your eye on that ball and having realistic expectations is very important as you go build all-flash array system or NVMe-based all-flash array systems. And with that, I'd like to introduce Julie. Julie, go ahead and take it away.
Great, thank you, Mike. Can you advance to our first slide, please? So as he said, I'm Julie Hurd, Director of Technical Marketing at E8 Storage. So E8 Storage is a pioneer in, oh, looks like my slides kind of went a little wonky. We're a pioneer in a shared NVMe storage array, and we've been in the market for almost 2 years now with both a high availability and a single controller appliance. I'm going to talk about these use cases obviously later in the webinar, but AI machine learning, of course, is a huge use case that's coming up now. Genomic sequencing, real-time analytics, financial applications. So these are some of the key target use cases that we've seen in our initial deployments and in production. Next slide, please. So NVMe, we knew, our founders knew that when NVMe was coming out, in order to really unlock that performance, we were going to need to take a different architecture. So as Mike alluded to earlier, the architectures of the existing generation 1 flash arrays, built on FPGAs, built on ASICs, they were all really centered around a single or dual controller architecture, which doesn't give you or doesn't leverage really that scale out and parallel access capabilities that are built into the NVMe protocol. So that's where we've taken that different approach with our system, where we have the E8 agent that resides on the host side that allows us to offload roughly 90% of the data path operations to each of the hosts that are accessing our controllers. So we support right now, depending on which drive we're using, up to 126 hosts that are directly accessing the NVMe SSDs in parallel via RDMA. And we support currently Ethernet and Rocky and InfiniBand. That allows us to really increase that parallel and take advantage of the parallelism that's inherent in the NVMe protocol. Because as everyone knows, the NAND underneath is exactly the same. We're just able to, with NVMe, get much more performance out of the underlying NAND. So again, more parallel access with our architecture. By offloading the data path operations to those hosts, we're now taking the controllers out of being a bottleneck to performance. And now we can linearly scale up performance with every host that we add. And we've shown in our internal testing up to 10 million IOPS, 40 gigabytes per second, both read and write, depending on your block sizes. So we really are, and this is using 100 gigabit Ethernet or InfiniBand. So we really are able to get the most out of the performance, not only of the NVMe, but also the network connectivity. So we've been proving this though, if you go to the next slide. Over the past year, we've been working on a lot of benchmarks. So granted, benchmarks aren't necessarily the best indicator of what your performance is going to be, but it does give you a standard playing field to understand for a given workload, how do the different vendors compare? So with software build, it's a build environment where it takes a lot of small files, builds them out into a very large make file, which you could actually equate that workload out to things like rendering or genome sequencing, where you're analyzing a lot of small files and coming out with a larger build result. So it is applicable to many different use cases. And in this case, we did not one, but two spec SFS results, and we partnered with IBM Spectrum Scale because it is a file-based workload and we are a block device. So we did that with first a 15 node GPFS cluster, but then we expanded it up to a 30 node in order to get even more performance on the software build results. So you can see our latency profile is much lower than any of the rest of the competition throughout the spec run. So we do have the record on the lowest overall response time while maxing out the number of builds that are there competitively. And we do it with just a 2U 24 drive NVMe system versus some of these larger builds that have much more hard drives and SAS drives with a better latency. Next slide, please. But we also focused on another use case for financial markets. And that's where we did a StackM3 benchmark partnering with McObject for their financial database. It's really focused on things like real-time trade analytics, next day business bid, those kind of trading analytics. So it is again, this slide did not translate properly. We did actually set records in 5 of the 17 operations. And on the read intensive operations, we actually were 17 times better than the nearest competitor. So you can see where shared NVMe storage does really unlock where we can actually show the big benefit of having NVMe drives, having an architecture that unlocks the performance of those NVMe drives. And even there are some results in here, we were competing against servers that had internal storage class memory. And we were able to do even better than those servers because we were able to bring many more drives to bear in a shared NVMe environment. So that is the introduction for E8 storage. I will turn it over to the next speaker.
Thank you, Julie. And those times are certainly very impressive. I think if you look at that, it really kind of shows how much improvement NVMe provides over standard SAS out of flash. All right, with that, I'd like to turn it over to Dan at NUISYS. Dan, go ahead.
Good morning, everyone. I'd like to thank Mike and the G2M team for organizing this event today to discuss NVMe use cases and best practices. As Mike mentioned, my name is Dan Liddell, and I'm responsible for marketing for NUISYS, the storage and server division of Sanmina Corporation. If you haven't heard of us before, don't feel bad. We've basically been in stealth mode for the last decade, providing storage solutions to and through major storage vendors as an OEM. We've recently kind of come out in recent months and then launched and announced products and platforms, which has been very exciting. In terms of myself, last 15 years, I've been running marketing and sales and BD for storage and storage virtualization companies. And then about a decade prior to that, doing the same thing as I worked my way up within networking technology startups as well. So that's a little about me. When we look at and start talking about the company, just to set some context, NUISYS is wholly owned by Sanmina Corporation, been operating for many years. We do have, although again, been a great kept secret until now with our strategy change and actually going out and doing external marketing, we have award-winning compute and storage platforms, not only in standard spinning disk space, but also now multiple platforms have won Best of Show awards in the flash space, specifically around NVMe as well. We'll talk about that in a minute. We've got a number of key market firsts over the years that we've developed in terms of our density and capacity, performance, and so forth. I won't go through each of them, but we were first to market with an NVMe PCIe JBOD, so think of it as a JBOD for flash. And we're also first to market with an NVMe over Fabric solution. Again, touch on that later. But basically, we focus on product innovation that delivers performance, capacity, and leadership. So overall, we're very proud of our industry first. We've achieved the awards we've won, and that's a little bit about this division of Sanmina. I wanted to set some context there. So with next slide, please. So in terms of of applications. We thought, we're going to talk about use cases, but we want to set context, applications for or of NVMe technology. So NVMe is a technology that has multiple applications and solutions. It starts with incredible performance at device level with NVMe SSDs, both from a throughput perspective and tremendous low latency, as Julie had mentioned in the prior presentation. But then we have the ability to develop next generation storage networks with NVMe over fabrics. With support for a wide number of network protocols and customer implementations, gives you great flexibility. When you combine these technologies at the drive and storage network level, an NVMe can enable a wide variety of applications and solutions, including all-flash storage arrays, NVMe all-flash servers, as well as hybrid and hyper-converged systems using a mix of spinning drives and NVMe flash. So tying these together is key, and that leads us to use cases. So next slide, please. So when we think about use cases for NVMe adoption, I think probably most of the folks on the call here today have a pretty good sense of what that is. And certainly Julie's touched on some key areas. But additional thoughts there would be around use cases for NVMe adoption, such as, we see clear short-term upgrade opportunities for customers to test and evaluate their workloads in a proof of concept fashion, and find incredible business value with the ability to boost performance for business critical database and other applications. NVMe SSDs are available now, obviously. NVMe over fabrics on Ethernet is available now as well, both from innovators and soon some larger incumbents. And then, of course, NVMe over fabrics on Fiber Channel is going to see a big ramp in customer adoption in 2019, we believe. From a medium and long-term migrations will definitely occur when the existing customer hardware assets depreciate, typically over a 3 to 5 year time frame. And when various SaaS storage and servers go end of life, IT organizations can start planning now to execute migrations to NVMe solutions as part of their sort of normal product lifecycle upgrade processes. We're currently in very exciting times as we see incredibly wide range of compelling applications that can benefit from NVMe. And we agree that these use cases we've just heard about from E8, but also there's things like real-time processing, online transaction processing, also known as OLTP applications. And you can see those in e-commerce, as well as IoT, where the accelerated speed can make a real difference. Obviously, we also see it in large IT investment in big data and intelligent analytic applications with AI, as mentioned, machine learning, and applications like Hadoop and Splunk for decision support systems. Vertical market applications where modeling massive amounts of data is critical to investment decisions with energy exploration in the oil and gas industry. And we can look at the healthcare system, which depends on, analytic modeling of genome systems and research. There's the powerful capabilities that can be achieved with DevOps applications as customers shift to virtual infrastructure across distributed IT data centers and the cloud with new innovations. We're now seeing with container technologies and tools from vendors like Docker and Kubernetes, which I'm sure you're all hearing quite a bit about. So this is very synergistic. Next slide, please. Talking about NVMe deployments and use cases, I think it's also important to touch on best practices. When you're evaluating NVMe use cases, we think that one area that's worth further highlighting here would be the importance of selecting a partner and platform with a broad NVMe solution portfolio, not point products, but you need the broad flexibility to support a range of purpose-built applications for maximum efficiency, both from a TCO and OpEx perspective. That partner should be able to deliver on a vision that protects investments today with future-proofing for financial business advantage over time. And the partner should also be committed to open architectures and multi-vendor interoperability and of course, the flexibility of choice for customers. I mean, the point here is this NVMe technology and the market is evolving rapidly. It is enabling new applications. It is very dynamic space. And as a result of that, your roadmap matters. The products you offer matter. The roadmap where you're taking that matters. And it's not a case of where one size fits all. So offering a broad range of platforms is key. And then we believe that multi-vendor interoperability of those components that go into the system is also critical because it provides much greater efficiency. If you can pull in and tie in, say, the particular flavor of NVMe drives to address your application, for example, I will go through it, but one of the platforms we won an award for was NVMe over Fabric solution, in which we were demonstrating the lowest possible latency out there in the market. And we won against all vendors out there. Everybody submitted. It was very exciting for us. And we, in that case, leveraged Intel Optane drives because their characteristics are great low latency. But if we were going through for maximum throughput, we would potentially pick a different NVMe drive vendor to put into this solution. So we think these things matter and are particularly important. Next slide, please. So to sort of wrap that up, because we believe interoperability is important, because we believe having a broad portfolio and offering lots of flexible solutions for customers is important, we have made a significant investment over time in this technology and in the platforms that we support. We currently today have the broadest set of products in the NVMe space. We cover a wide range of capabilities. So, when I think about, so if you think about, like, for instance, the NVMe over Fabric solution demonstration that we just did with partners at the last Flash Memory Summit, we attained record-breaking, unparalleled performance. And this, again, was in a multi-vendor scenario. We hit 15 million IOPS. This is a little 2U, just a 2-rack U box. 15 million IOPS. We hit 64 gigabytes between the servers, but we were seeing 61 gigabytes per second on reads across the unit. And all of this was accomplished with only 7 microseconds of added latency in the fabric itself. So very, very low latency, high performance system when you're talking about a mesh fabric that this one happened to be connected via Ethernet. So this gives you a sense of the kind of things that you can do. And of course, as a company, we are very proud to have won back-to-back Best in Show awards at the last 2 Flash Memory Summits when our platforms are stacked up against all vendors out there, whether large and small. So that's a little bit about us. And with that, I'd like to thank you for your time and then hand it back over to Mike.
Thank you very much, Dan. And finishing up the vendor part of this is Tom Spencer from SolarFlare. Tom, go ahead and take it away.
All right, thanks a lot, Mike. So first and foremost, I botched the slides that I sent over to Mike. My apologies. Most of what I need is in here, but I will speak to a few items that are missing that are very critical. So SolarFlare, if you're not familiar with our company, has established itself as the #1 vendor for Ethernet adapter cards in electronic trading. So with 90+% market share worldwide, every major exchange in the world uses us. And what we've been able to do is optimize TCP and UDP transport, which segues right into this discussion. So if we look at NVMe over Fabrics, obviously we're doing network storage. I'm not going to walk through this list of applications and business drivers here. So Mike, let's go to the next slide. I'm going to focus on the opportunity that NVMe OF with TCP presents. So today in the consortium, there exists InfiniBand, there's 2 flavors of RDMA, and there's Fiber Channel. TCP as a transport is going to be up for vote this month. We have a high probability of success in the first round, which means it'll be added to either version 1.1 or 1.2 of the spec, the NVMe spec. And what this does, you talk about opportunities, business opportunities. It opens up the doors to legacy infrastructure, any switch, any endpoint. Everybody supports TCP. And the initial solution that's being put out in the market is a Linux kernel plugin. And that means it works on anybody's Ethernet NIC that has a Linux driver. That's ours, that's all of our competitors, everybody. And so if you look at this table that I have in the presentation, Ethernet has low latency. We've proven that in high-speed trading. Lossless, deployable, scalability, ubiquitous. 98% of all infrastructure is Ethernet. So the other technologies are excellent technologies, and they have use cases. With Ethernet, we have the opportunity to go into legacy infrastructure and use generic equipment. We can use white box, we can use labeled products. That brings big opportunities. Let's go to the next slide, Mike. So this is from the consortium. As I mentioned, later this month, there's supposed to be a vote on TCP as a transport. SolarFlare has been working as a contributor since mid of last year to the spec. We're in good company with the likes of Lightbits and Facebook and VMware and others that are in the consortium, in the working group. So we're contributing members. We've been at Flash Memory Summit the last 2 years, demonstrating TCP as a transport. Let's go to the next slide. I think we went backwards, Mike. We went backwards. Okay, so this came from, this is looking at IOPS. We're going to look at IOPS and latency. So sustained 4K mixed, we had 70% reads and 30% writes. This is a kernel driver. And what we're showing in this slide is if you take a local, which means a direct attached storage of a NAND storage device, which is the upper line there, the white line, and then if you take our kernel driver on a SolarFlare adapter, we're within, I would say, 8 to 10% of direct attached storage. We're within 3 to 4% of Rocky on a kernel solution. We have both initiator and target solutions, both. And basically what this is saying is TCP is as good or perhaps good enough as other transports to deliver network-based storage. If you go to the next slide, should be the latency slide. It's a similar output. Now, when we went to the Flash Memory Summit this year, and this is one of the slides that I wanted to have in here, and I just messed up. We took Optane drives, which if you look at a NAND device, direct attached storage is about 70 microseconds of latency. An Optane device is around 10 microseconds. We were able to deliver a 15 microsecond solution over a network using our accelerated TCP. This is using our same technology as we use in electronic trading. And the best part of it is that solution is transparent to any application. It does not know that we're accelerating the TCP. It just benefits from the performance. So here we have read latency measurement. This is the kernel version here. If I had this other slide, I would show it to you guys. We basically, from a kernel solution, network-based solution with an Optane device, we can actually reduce the latency and improve the IOPS up to 55% on an Optane-based solution. That's using standard TCP, and you don't have to have us on both ends of the wire. You can have anybody on the other end of the wire. So that technology is what we're pushing for all flash arrays. And this is enabling all flash arrays to have near direct attached storage performance over a network using standard TCP. I think there's one more slide, Mike. Perhaps not. Yeah, these are more of the use cases. So database applications, we're seeing a lot of. We're actually building reference platforms where we're not only accelerating the TCP for NVMe OF, we're actually accelerating database applications, database caching use cases with Memcached, Redis, SAP HANA. And so you put an all-flash array for your backend storage, and you've got database applications running in front of that. We're accelerating both elements, getting 300–400% increase in performance on the database applications. Again, standard TCP. So that's what, if you guys haven't heard about us, if you want to look into what we have, you guys can contact me or contact me through Mike. And we can show you what we're doing with TCP as a transport for NVMe OF.
Thank you, Tom. That was great. So let me go to the first question. So this question is, what do you see as the key use cases for NVMe and NVMe over Fabric all-flash arrays? We'll start with Julie at E8 Storage. Hi, Julie, are you there?
Yes, I am. I apologize. I muted myself and forgot to unmute.
No worries.
So the blanket answer to that question really is we're seeing people that have applications that drive their business revenue. And those are the folks who are the earlier adopters of the new technologies that really do need that low latency and very high performance to really maximize the revenue they're making from their applications that are using the high-speed storage. So top of that list, genome sequencing. And this is not necessarily revenue, but it is research. And that research is driving things like cures for cancer or new therapy regimens for any kind of diseases. We have several customers now in the genome sequencing space that are using NVMe, shared NVMe from E8 storage, as a high-performance scratch space tier to get the really fast results they need on the active processing across multi-node clusters. And they integrate that into things like Geneva Grid Engine to do automated scheduling, bringing up and bringing down volumes as needed to drive that really high performance analytics. So folks like Oxford University is a prospect of ours who did some real-time testing with us, European Bioinformatics Institute, Premier University. Now that they are starting to, now that the first one has started investing and seeing really how much they're speeding up their applications and speeding up their genome sequencing, other folks are following suit. So for one customer application, they were able to go from taking 10 hours to do one genome to being able to do 10 genomes in an hour. And then they are talking about then the secondary genome analysis, where you take a very large data set and start doing comparisons across all these genomes. Well, now that you have shared NVMe storage, they can do much larger data sets, which means that their analytics and their results of, what gene, causes blue, or blue eyes or whatnot, they can actually take that a much larger sample than they could previously, now that they can do more shared NVMe. Another use case that we're also seeing, of course, artificial intelligence is really coming up as the next hot thing. And that's because you can now automate a lot of things that used to take humans a very long time to do. With some of the new neural networks that are out there, machine learning can be done faster, and you can get more accurate results for things like image recognition. We're doing a use case now with folks like Hong Kong University, where they have done some side-by-side testing of NVMe, not only inside their GPU node, but also across being able to use it as shared storage behind a GPU node, whether it's NVMe inside or NVMe on the back. But with shared NVMe, we can bring more drives to bear, so we're able to get better throughput than you could off of internal storage, as well as we're getting lower latency. So artificial intelligence, machine learning, the more data you have, the deeper your learning is, which means your results are more accurate. And then during your analysis, being able to process more images per second is very important to the end user, so they can get a lot more, their accurate results faster at the end of the day. And image recognition as an application spans a lot of use cases. Things like, of course, automated cars is one of the first ones that comes to mind. Facial recognition for police, for the police and other, law enforcement agencies. But even things like manufacturing will do image recognition to do real-time recognition of faults and defects in a manufacturing line. So that the artificial intelligence image recognition, again, becoming up as a very important application that is starting to adopt NVMe, because when you start looking at things like having a multi-node GPU cluster, you don't want those expensive resources sitting idle waiting for data. So they need the fastest data they can get, very low latency. So those are some of the use cases. And of course, the financial markets. Anytime you start talking about bleeding edge applications and bleeding edge, storage adoption, the financial markets are the first ones there, because having the latest data on the trades and the trends of the market means that you are driving your next day trades based upon what's happening now, even real-time analytics. So then that's financial markets that can be mean $1 million or $2 million, $5 million swing every second if you're not making the right trades. So they're obviously the first ones to do it. And then finally, there's actually one interesting set of use cases, and this is actually for fluid dynamic simulation. So folks that do electronic design automation for multiple use cases want to be able to make sure they test out those designs electronically before they build it. And so they do fluid dynamic simulation on an HPC cluster. So you've got folks like building Formula One race cars, and they need to do fluid dynamic simulation to reduce the wind drag as absolutely much as possible in order to win that race. That's millions of dollars in prize money. But we also have a prospect that's an architectural firm who designs things like bridges. And so now they're looking at accelerating their HPC cluster for doing the fluid dynamic simulation for wind, rain, traffic. How does this design going to stand up over time? So again, this is where they make their money with their applications. And those are the folks that are really assessing NVMe.
Excellent. Thank you, Julie. Dan, what do you guys see at New ICES? You see any other additional use cases besides the ones Julie talked about that are interesting for NVMe or NVMe over Fabric?
Well, Mike, yeah, Julie did a great job covering quite a few use case and application notes, ranging from AI to genome sequencing to financial markets to fluid dynamics. I mean, really did a good job covering that. We agree, and we think those are excellent use cases. We're seeing those with customers. We're seeing those in the market. We do have some additional ones that we're seeing out there from a practical perspective with customers and engaged who are analyzing this and doing POCs. I won't spend time talking about the big data analytics applications because that ties in closely to the artificial intelligence and machine learning and Internet of Things that she has been touching on and how timing can really affect things and impact millions of dollars. But other areas that we see is also in virtualization and container infrastructure, where addressing the high performance requirements of applications across distributed data centers and private public cloud deployments is important. Sort of everyone understands, I think, or many folks now understand the compelling value of virtualized infrastructure and the greater levels of optimization that can be achieved with containerized solutions. Some of the challenges that come up along the way there, though, for this type of application infrastructure is the potential for noisy neighbor issues or potential I/O bottlenecks, and the unpredictable spikes in overall throughput and application performance. These sort of things can create potential quality of service issues. So NVMe all-flash arrays can mitigate those challenges by delivering consistent and stable high-performance infrastructure that meets those service level objectives. Another application that we see a great fit or use case for NVMe would be online transaction processing. Those databases that are real-time, very sensitive to latency. So OLTP, to address the core business critical applications, those demand the highest levels of performance and scalable capacity, coupled with the requirement for non-disruptive operations to meet the most sort of demanding application needs. A wide range of examples for that. We can all relate to OLTP workloads that demand speed, such as airline reservation systems, a consumer product purchase on a peak day of the year like Black Friday, or even a mission critical stock exchange investment transaction as mentioned by Julie. So these type of applications require consistent nonstop operations coupled with extreme performance to create this reliable environment where speed, both IOPS, throughput, latency really matters. So an NVMe all-flash array can deliver in this scenario very well. Another application that we see that wasn't mentioned is sort of along the lines of business continuity solutions for sort of nonstop operational systems, which typically need scale out in overall enterprise framework to address, the on-premise data centers, integrated into cloud storage environments for a hybrid model. When real-time processing demands synchronous replication, so synchronous replication of content, this benefits greatly from NVMe technology. So the idea here is doing this has the potential to deliver a zero recovery time objective or recovery point objective. You're familiar with the RTO and RPO terms, and you can get 5 or 6 nines uptime, even if the site goes down. So, with an all-flash NVMe all-flash array, this type of 7x24 operational support makes a lot of sense. It is worth noting that basically all of the applications we've described and that Julie described to myself, they have sort of 3 vital functional components that are necessary. They each require high throughput storage for data ingestion. They require, in this case, a distributed database that scales out for data processing and capacity. And they also, of course, require low latency, high bandwidth networking for the clusters of servers. So, we see these aspects as being very important. And this is one of the reasons, again, that we had put together a live demonstration, a very real world demonstration at recent Flash Memory Summits, both the one we just completed a couple months ago, and then the one a year prior to that. And in those scenarios, we took a real world setup and put together solutions leveraging our 1U storage server with NVMe. We also had an NVMe-based 2U JBoss device. We had a storage platform, NVStore OSX storage platform for persistent storage, and we built all that around some Intel Optane drives, and we were able to just see absolutely tremendous results from that. We were seeing 7 microseconds added latency across the mesh, which is pretty mind-blowing. We were seeing those over 60, 61 gigabytes per second throughput and 15 million IOPS. So very impressive, and we were pleased to win those awards. So that's sort of, that's what I would add to the conversation there. Back over to you, Mike.
Excellent. Tom, how about you guys from the adapter side? What are you guys seeing as the big use cases?
I'm not going to repeat that laundry list that we just heard because they did a great job highlighting them. I will say where we're seeing a lot of activity from our side. So as I mentioned, you know, we're big in fintech, and one of the activities that we call it crossing the aisle. That's moving from the trading side to the IT infrastructure. And a lot of our big customers are looking at all-flash arrays that they've done in the past with either fiber channel, very few with iSCSI, and moving to an Ethernet-based solution with SSDs. So moving to the new NVMe-based infrastructure. So we're doing some POCs with some of those entities right now. And it was also mentioned earlier with database infrastructure. Because we accelerate database applications independent of the storage, and then you combine that with the all-flash array infrastructure, there we're getting a lot of activity. So I would say those two areas are probably the most common with the AFA solutions. One other thing I'd point out too, Dan had mentioned not just the low latency, but the deterministic nature or the low jitter nature of the network. Our technology, the accelerated technology that we have, is a near zero jitter infrastructure, which allows us to have very deterministic behavior. Doesn't matter if we're running an application in a cluster, if we're doing storage, doesn't matter. So in those areas where you need the deterministic nature of the network, that's an area where we shine as well.
Excellent. Thank you, Tom. And with that, we'll go to the first audience survey question. We're going to have 2 of these. So I'll launch the first one here. And the question is, what use cases are most compelling for you for NVMe or NVMe over flash-based all-flash arrays? And this is a check all that applies. So just let us know which ones they are, and we'll go from there. You should be able to get on these from the Zoom control panel. Just answer a question. I'll give you about 60 seconds to do so. All right, I'll go ahead and end the polling. And by the way, all these results we will share with everybody in the slide set. So let me go to the next question here. The results, you should be able to see those. And we'll go to the next polling question. And the second question is your organization deployed or planning to deploy NVMe or NVMe over fabric-based all-flash arrays in the near future? And check one answer, please. All right, and with that, we will move into panel question number 2. We'll start this one out with SolarFlare. So even though all the major storage companies now support NVMe in their all-flash arrays, NVMe over Fabric is still in its infancy in all-flash arrays. What do you think it'll take for NVMe over Fabric to take off in all-flash arrays? We'll start with Tom, then we'll go to Julie, and then to Dan. Go ahead, Tom.
All right, so there are a couple things there. You know, it sounds a little self-serving from my side, but obviously we've gotten a lot of feedback from Fortune 100, Fortune 500 companies, the IT departments, the cloud customers, the telco customers, that as much as possible, they'd like to use TCP because of the ease of deployment, the ubiquity, the legacy infrastructure. It just simplifies things. So if they can get the results that they need from a performance perspective, then there's a preference there. Now, like I said before, there's going to be a lot of use cases that warrant some of the other technologies. I think more Rocky than any of the others would be the likely candidate. But I think TCP is going to open a lot of doors. Now, we've been waiting for the spec to get ratified in the consortium, which should happen this month. I don't see any barriers to it. But I think even beyond that, once the solution gets pushed up into the Linux community, I think that is going to create a pretty big opportunity in the industry. And as the Linux distributions start to take that plugin and integrate it into their distributions, so whether it's Red Hat or SUSE or Ubuntu, and they roll out with their standard distributions, I think that's really going to create an opportunity, because now you've got servers that are sitting out there that have standard OSs, and it'll just be native inbox inside the drivers. The other thing that can open up a lot of doors is getting other operating systems to adopt the technology. If I had to guess, I'd say VMware would likely be next, followed by Windows. But a lot of these use cases, if they're performance dependent, are largely going to be Linux anyway. So I think the heavier requirement is going to be getting TCP ratified and getting it pushed into the Linux kernel. I think that's going to be something that opens a lot of doors.
Excellent. Thanks, Tom. Julie, what do you guys see? Obviously, you're using NVMe over Fabric. Where do you think its role fits in all of this?
So just adding NVMe to an existing array, unfortunately, doesn't unlock the performance of NVMe, and it's something that E8 storage is said over and over again. So in order to really accelerate adoption of NVMe over Fabric, these players are really going to need to update their architectures, or at least update their stacks, to allow an NVMe end-to-end NVMe from the host back through to the drives. Anytime you take it back through a SCSI translation layer, you just lost the goodness of NVMe. So on the big all-flash array players, they've got some work to do in order to really unlock the performance. But to build on what SolarFlow just said, agree that as the different OS distributions really start supporting NVMe natively, that's really going to help it take off for NVMe or Fabrics. Not only TCP, but also, I think for me, more importantly, it would be the hypervisors, because a lot of folks, despite the fact that the high performance computing space, this doesn't necessarily lend itself to virtualization, there are still a lot of houses that want to do job-based workloads where they want to use a hypervisor and containers, bring up and bring down environments dynamically depending on what applications they have to run that day. So getting more native hypervisor support, getting native drivers into not only Linux, but again, yes, Windows and others also help the adoption. But the all-flash array players, to get them to adopt it, they need to really update their architectures to have native NVMe end-to-end.
Yeah, I think that's a good point. I think what we've seen in the array world over and over again, adding a new interface or adding a new media doesn't mean you've optimized it. So, very good point. Dan, from New ISIS, what do you guys see?
Hey Mike, if I could just comment on one of the things. Sorry, if I could comment on one of the things, because this is big, and we've seen this in the benchmarking, that what Julie pointed out is that translation of SCSI to NVMe. If you're not doing native NVMe transport, you're completely killing all opportunity to take advantage of the SSDs. I completely agree with that. And I mean, it's huge. It's not a 10%, 20%. It's a huge delta in performance. So when you look at all flash arrays, you've got to find the solutions that are native transport. Completely agree.
Excellent. Dan, what do you guys see from New ISIS's perspective?
Thanks, Mike. Yeah, I generally agree with the comments made by both my peers, colleagues on this call on this topic. But I do think that there can be a staged evolution. Like you will see significant advantages by deploying in an interim step just NVMe technology in standard systems. And then, of course, though, it is true that if you can optimize for those all the way through, then you're going to see even better performance over time. So I think that is definitely the end game, and we, of course, support both and agree with that wholeheartedly. Regarding my overall sort of response and thoughts on the question itself, we are optimistic that the trend in accelerating technology adoption will continue with NVMe over Fabrics. These adoption cycles for storage networking have, demonstrated a pattern of declining by almost half with each new generation of technology. I think many people can remember, like an example, like fiber channel SAN required about 10 years for broad adoption, but then iSCSI required about 5 years. And if this trend continues, then you could see NVMe over Fabric adoption might occur, in large scale over a 2 to 3 year window. The adoption of NVMe over Fabric is paced by sort of two key factors. I'd say the first one is customer awareness, but also their planning and expertise or knowledge about NVMe over Fabric. And then the second part is sort of availability of products to support customer demand, right? So you need having solutions out there that are relatively complete and mature and understood is key. So a business that wants to begin with NVMe over Fabrics on Ethernet can start doing that today, right? We talked about that. But if someone's saying, hey, I want to leverage my existing investment and management processes for Fiber Channel, and they want to leverage NVMe over Fabric using Fiber Channel, this will delay things a little bit, simply because that is being rolled out as a second stage following the Ethernet, which has already been out. And that's simply because there's just a certain amount of testing and qualification, certification, and so forth that needs to be done before you'll see general broad market acceptance. That's a normal and natural process there, and the learning as this is being navigated for Ethernet will expedite things on the Fiber Channel side as well. So the system integrations work includes applications, database, file systems from the software stack, and then there's sort of the integration with the servers and adapters that peers are talking about, the fabric switches and other hardware components that need to be fully vetted and interoperable with all of the Fiber Channel storage implementations that are out there and that customers are looking for. So although there's some NVMe over Fabric utilizing Fiber Channel today, it's behind the 100 gig Ethernet implementations, although close behind. And there will be a phased rollout over time by most of these vendors, these solution vendors, over the coming year as you go. So in other words, a business that wants to deploy NVMe over Fabrics today can readily find products from us and others supporting that Ethernet, and then moving on to Fiber Channel over time. Ethernet performance workloads with iSCSI-based SAN makes a lot of sense, and in this case, we're seeing adoption of these products really began sort of early 2018. There was discussion of POCs prior to that. And again, those guys who are looking to really leverage Fiber Channel will be behind that. They can plan for that to deploy in their normal hardware upgrade cycles and do a cutover over time in multiple years as they go. But like I said, it's just even if you're thinking about Ethernet, though, you do need to upgrade some of those components to support the NVMe as well. So there's a process here, and it's being navigated. It's moving along quickly, and we see that real-time adoption happening now.
Terrific. Thanks, Dan. Let's go to survey question number 3. I'll go ahead and launch it. And the question is, how important do you think that support for NVMe over Fabric is in an all-flash array? And please check one answer. We'll give you a minute and a half to go ahead. All right, let me share the results. Obviously, it looks like most people think NVMe over Fabric is a good thing for AFAs. So again, these results will all be in the slide set when we put it out. So let's go to panelist question number 3, and we'll start with Dan on this one. So a lot of press in our industry has stated that NVMe flash media has allowed storage appliances, in other words, systems that are servers running third-party software, to nearly catch up with all-flash arrays. What do you see as the greatest strength of an all-flash array relative to storage appliances? We'll start with Dan, then we'll go to Tom at SolarFlare, and then we'll finish up with Julie. Go ahead, Dan.
Okay, thanks, Mike. So, at New ISIS, we have good credibility in this topic, because of our very rich product portfolio, investment in time and energy, and learning that technology over many years now. And that portfolio includes, NVMe-based storage appliances, NVMe all-flash arrays, as well as a long history of all-flash SAS arrays, storage servers, and hybrid systems. So the answer really depends on what IT challenge it is, that which particular IT challenge is looking to be addressed by that customer. So SSD storage appliances typically include only basic storage management feature sets and tend to focus more on performance. Examples would be for HPC and media entertainment applications who really need the performance but don't necessarily need all of the advanced data service capabilities, nor are they really willing to accept any performance degradation or added costs for those services. So they're really, targeted set who benefits a lot from the appliance side. All-flash arrays, also known as AFAs, provide a rich storage management stack with robust data services, including the things like thin provisioning, cloning, deduplication, and compression in order to optimize capacity. They also have things like snapshotting, erasure code, encryption, and replication for data protection, right? So, each of these capabilities introduces processor overhead and can degrade IOPS, but it's a worthwhile trade-off for those applications that need them. So there can be hits there as well. So some applications, many would like that, benefit from those features and those capabilities. Others who just want pure performance would not. So, these portfolio that we have embraces both of these approaches and provides flexibility and efficiency in matching these capabilities. So you match the capabilities of the underlying platforms with the distinct requirements of a particular application, and you have a more efficient, effective solution, which links back to TCO and its overall cost of ownership. So we find this providing the greatest value and efficiency for the infrastructure investment made by the business overall, and that's an important consideration. So again, we look past that. We support those AFAs, we support the storage appliances. We also support platforms for hyper-converged infrastructure called HCI. So we give a lot of flexibility, and that's sort of I guess that'd be our high-level view of this. So that's really what I have to say at this point. Thanks, Mike.
No problem at all. Tom, what do you guys see as the major advantage of AFAs versus, say, storage appliances?
I think that the turnkey manageability and data protection are probably the biggest elements, and something in a box that's fully tuned and fully configured and tested and validated. It's got to be the number one thing. So obviously, the fact that it's all flash, you're going to get the performance. That's assuming that you've taken all the necessary steps to optimize performance over the network. But I think performance, manageability, and data protection, I think, are the key elements, all turnkey.
Excellent. And Julie, I'm sure you're going to have a strong opinion on this one. Feel free to walk us through and take some extra time if you want to.
So I actually think it's the wrong question to be asking, because it's really about whether it's deployed as an appliance or an all-flash array. You're talking about the software stack and what your software focus is on the architecture you've derived. So just whether it's NVMe flash media, that's we've architected, of course, at EA Storage to really unlock the parallelism of flash media, and we have focused our development currently on a very high performance use case. Adding the features of how you described all flash array, that will come over time. I mean, we're a fairly new startup. So the general purpose all flash arrays that have been around, I do have more, more of the feature data management application, data management features really is something that comes along with time and development. I think the important thing to consider though is how you take it to market. Software-defined storage has had a long history, and with NVMe, it's just a different architecture of software-defined storage because the hardware underneath really is just becoming off the shelf. Folks like Newisys is a stellar provider of a fairly large array of off-the-shelf hardware that you can add software to, as are any number of ODMs. So it's really about where do you focus your software development and how do you take that software to market. To a comment that you had made very early on, purpose-built flash arrays or purpose-built appliances based on ASICs and FPGAs, those really have gone by the wayside in lieu of an x86 architecture, because it is the performance of x86 has come up, the ability to optimize your software stack depending on what your workload is. that still lends itself to x86, although things like ARM processing are now really coming to the forefront for things like SmartNICs and being able to do offload for, like for us, for our host agent. So whether you'd an appliance or a flash array, it depends on the workload that you want it to apply it to. If you want really a performance at all costs, obviously a purpose-built appliance will help that. If you want a general purpose computing or general purpose storage that has a lot of features, then it's really all flash arrays.
No, I think that's a great response, and I think you hit upon a key point. And that I think it's easy for us to think about all these services that are out there, and there's a lot of checkbox comparison between new companies and old companies doing arrays, but a lot of those services came about in the disk world, and maybe are not as relevant today. Just like ASICs and controllers have changed a lot too. So, thank you for that. That was a great response. And with that, let's go ahead and launch the last poll question, then we'll go into the Q&A right after that. So the poll question is, what NVMe over Fabric transport options will your organization consider or require when purchasing NVMe over Fabric all-flash arrays? And you can check all that apply. Go ahead. Polling's open. So thank you. So the first question that we have on the Q&A, and I'll let each of the panelists respond, is, are there any specific automotive or industrial applications that NVMe is particularly well suited to handle versus other types of memory?
Mike, and I'm happy to take a stab at part of it.
Perfect.
So one that just comes to mind that we actually have a POC with customers working on is the autonomous driving vehicles. I think that was listed as one of the good use case applications. So there's systems that they gather tons and tons of data from these as they drive. They're gathering an amazing amount of data. They collect that data. There's actually units in the vehicles that are being tested and developed, and then there's also offload as well. So then there's real-time analysis happening when you think about the decision processes that have to be made while these cars are driving. So that's one aspect I think that just comes to mind right out the gate relative to automotive.
Excellent. Tom, Julie, you guys have any opinions on this one?
Nothing to add from my side.
Yeah, I was trying to think of some applications, but everything that comes to mind tends to be one, what was already said, but also tending to be more financial applications. So I didn't have anything specific to add.
No problem. So let's jump to the second question. And this one is, in my opening remarks, I mentioned that most storage array deployments are based on x86. This seems to be the opposite of the stories told by vendors in this field. Mellanox Solutions deploy many, if not all, of the most current NVMe deployments. Just to clarify, when I'm talking about x86, I'm talking about the controller space, not about the adapters or anything else. And as we all know, some adapters are accelerated, some aren't. Julie, Tom, you guys want to jump in on this one, or Dan?
Oh, well, of course, E8 storage, all of our IP is in our software, and we deploy on x86-based appliances that we source from hardware ODMs. Again, and you're talking to someone who hails from BlueArc, where we were an FPGA-based architecture. But with the acceleration of x86, you really get all the power you need along with the general purpose computing that comes with an x86 architecture versus an ASIC or FPGA. So I think the need for FPGAs and ASICs has gone by the wayside, and being able to reduce costs by using a standard x86 architecture benefits not only the vendors, but also the customers.
Absolutely. And I think I tend to agree with you, not to mention the fact that software development on x86 is far simpler than it is building it for either FPGA or ASIC sort of solutions. Tom, what is your opinion on this? Do you have any opinion?
So, I need to make sure I understand the question. Is it FPGA for the networking versus standard adapters?
I would assume that is the case, yes.
Okay. Proprietary solutions being worked on through FPGAs, and I don't know, that this is going to be a matter of choice. From our portfolio, we're going to have both bases covered. But if you look at, if the performance is on the networking side, that's one side of the equation. We have that covered either way. If you look at what the goal is to basically remove the x86 box altogether with these FPGAs. In my opinion, I think it's doable in time, but I think it's going to be a tall order in the near term to completely remove it. You also may see some ARM implementation, so an ARM plus FPGA. Could be an ARM embedded in FPGA. That's another path that's possible. But in the near term, I see standard x86 boxes, maybe for another, couple years, at least as a mainstream. Just NVMe OF, as we talked about it, one of the questions was, what's it going to take for NVMe-based all-flash arrays to gain, market share, or to become prominent in the market, I should say. And that has to happen first. But there are definitely people working on these FPGA-based solutions. So we'll see. We'll see where they land. I would also not underestimate the difficulty of implementing an actual Ethernet networking stack. There's a reason why there's a collaboration between us and Xilinx, which was, public information. You don't just slap an Ethernet MAC inside of a FPGA and run with it. So there are definitely some hurdles to be overcome, but there may be some solutions that work well with that. I just think they're a little bit further out.
Dan, do you want to throw anything in on that one?
No, I think Julie and Tom covered that well. I think that we basically agree with those points.
Excellent. Next one is, second one. So the next question is, for which NVMe over Fabric AFA use cases do you think the inherent higher latencies of TCP will make NVMe over TCP prohibitive when compared to other NVMe over Fabric lossless transports like Rocky or Fiber Channel? Tom, I'll let you take the first shot at this one. I'm sure you have a strong opinion on it.
I do. We've got data that says we're within 3 to 4% of Rocky. So I challenge the question that we're not as performant. If you look at, for example, a NAND SSD at 70 microseconds, direct attached storage, and Rocky's in the, say, 77 microsecond, and we're around 80. I'd say we're in the ballpark. It's not a big step. It's not 20% or 30% or 40%. It's a single digit, low single digit, the difference between Rocky and what we have. And then on top of that, we have the TCP acceleration. We're the only company that does it. And it's transparent to the application. It's transparent to the user. So you can have 100 initiators on the far side with the kernel plugin that's going to be ratified here in the very near term, banging on an all-flash array that's got our accelerated TCP stack, and they're fully interoperable, 100%. So we have had conversations with very large hyperscale companies, with top Fortune 500, Fortune 100 companies, and the telcos, and the feedback is unanimous. Most use cases will prefer TCP, full stop. And as long as the benchmarking continues to prove out the performance, then there's not going to be a big debate over it. So that's my perspective on it.
Good deal. Julie, what do you want to add to that? Or do you want to add anything to it?
I do. I think I don't disagree with everything that that Tom just said. I think the challenge will be that when people start wanting to use their existing networking infrastructure with TCP, with NVMe over TCP, I think they're going to find out exactly where their bottlenecks are, because now that you have very high performance storage, it's going to really highlight where the bottlenecks are in their network infrastructure if they're trying to use an existing one, which is one of the interesting advantages of when we're working with customers to do Rocky. It's because they're having to install a new switch, and you do, with the 100 gigabit Ethernet. And so now they're getting very high performance because they have a much higher performance switch versus their legacy switches. So I think that's going to be just one of the things that comes up. I don't disagree with Tom's assessment. We have not done any benchmarking personally or at 88 storage to really kind of say one way or other. We're just waiting for the standard to be ratified.
I think it's a good, it's a good point. I think, when we think of storage networks, again, I worked in all the fiber channel companies as well. And you certainly have different issues once you go to a converged SAN LAN. I think so. So regardless of whether it's TCP or Rocky or whatever, when you put SAN LAN traffic on Ethernet, you certainly find out where your issues are. That there's no doubt about that. Dan, you want to put an opinion on this one?
Again, I think going third here, it definitely feel like it was addressed effectively by both Tom and Julie. With our sort of real world application deployments that we've been doing, we wholeheartedly agree that's exactly how you determine where those bottlenecks are. As you jump up the throughput and infrastructure itself, you hit those, you learn and navigate through it. Relative to the TCP versus Rocky side of things, we're not seeing a really big delta, I think, in support of Tom's point between the two. So certainly there is. It's in the magnitude of 3 or 4%. That's reasonable. It's not noise, but it's not tremendous. So I guess that'd be my reactions to their comments. Generally agree, though.
Perfect. Okay, last Q&A question we have. We're aware of the latency and throughput advantages of the new AFAs. I assume he means NVMe AFAs there. But are there any major improvements that customers are looking for from these solutions? And I'm going to assume that what our attendee is asking is, are there new things people are asking for that they didn't ask for in older disk-based systems? Julie, do you want to start with that one?
I don't know that they're asking for anything new, but a conversation I was actually just having last week, they're just wanting to make sure they're staying ahead of the performance curve. So we were talking, one of the customers that we are engaging with in the UK, we're now, what used to be now what was their high performance tier is now moving down into more of their general purpose storage because it's not the highest performance thing anymore. And we're going in as the new high performance tier. So again, as the technologies evolve and get faster, what was fast now becomes not so fast. So they're really, for the NVMe, looking for this as, again, their new fast tier of storage, as what used to be fast isn't fast anymore.
So it's really driving that performance for those high performance use cases. What they're really seeing is what you're seeing is the thing people are expecting.
Yep. And especially as new use cases like the artificial intelligence are driving image recognition with huge GPU-based clusters. Those are really driving a much higher tier of performance requirements than was in the past. And it's just a new use case coming up that needs just more computing and more storage.
Excellent. Dan, what do you guys see?
I think hard to argue with any of those points. Very general, they make a lot of sense. We come up with a newer, faster system with low latency, and you'll see the natural evolution. As Julie mentioned, what was ultra high performance is now just sort of high performance or primary. We see that continuing, and we deploy with that in mind. People are just trying to stay ahead of the curve. Trying to think if there's any other aspects here that would be interesting. One thing that's important and interesting is that the capabilities and the cost points of the NVMe are changing rapidly, and it's enabling a whole slew of new applications, many of which we covered earlier in this presentation, hitting on the different use cases. So the breadth of areas that these applications can touch and that these technologies can address and solve problems in new ways that were not done before, I think is going to continue to grow. So I do think there'll be, in addition to the staying ahead of the performance curve for existing applications, I think there's going to be more and more growth in the other applications that these technologies enable. I'd just add that.
Excellent. Last, Tom, what do you want to put in on that? Anything new that people are asking for? Oh, I think you're right. All right. Well, with that, just thank you, everybody, for being part of our webinar. As I said earlier, we will post both the slides and the recording of this, and everybody who registered will get a link. Thank you for Julie, Dan, and Tom for sponsoring the webinar, and We appreciate it and have a great day. Thank you.